So, hello everyone. Thank you for being here and warm welcome. So, we are very happy to be at our first KubeCon, and we'll be sharing the insights on building a LTS version of Kubernetes, insights and lesson learned. So, before kicking off the session, let us introduce ourselves. My name is Yash Kumar Singh. I'm a software engineer at VMware. I basically working on releasing the Kubernetes and its core components and building and validating them for Tanzu.
Hey everyone, I'm Arka Saha, also working as a software engineer at VMware with my fellow colleague Yash here. I'm responsible for building, testing, and releasing Kubernetes as well as maintaining the CI infrastructure for Tanzu.
A big shout out to Kubernetes community, especially for our team at VMware, basically helping to embrace this journey of LTS together. So let us look at what we have in our agenda. We'll be discussing on what is LTS, why it is needed. Next, we'll be exploring on challenges when defining the LTS, the implementation to support LTS, and the key takeaways. So what is LTS? LTS stands for long-term support. So it helps in defining the basically supporting and maintenance policies for end-of-life releases. Next, the security updates and bug fixes, which can include the CVs and all. So we can basically enlighten the in the LTS policies. And lastly, how we can optimize the upgrades and the maintenance expenses.
So let's start with why it is vital. So basically, community supports LTS for roughly 14 months, out of which the first 12 months is general support, and the last 2 months is basically maintenance support. So that gives a very short period of time for vendors to upgrade to the next version. Next, enterprise customers want longer support timeframes, which basically means that they want to stay on a stable Kubernetes version for a longer period of time, so that they can plan their next upgrades and basically the rollback and downtimes. Next, the quality of Kubernetes should not be compromised due to bugs and CV fixes. So as a Kubernetes version gets old, the CV versions and actually start coming in, and those don't land on the out of support Kubernetes version. So that's why LTS can ensure the quality of Kubernetes. Simple upgrade path for out of support releases. When we are talking about LTS, we should also provide the vendors a proper and a simple way to upgrade to the next versions, which basically means that they will have time and planning to do the upgrades, whether it be a skip level upgrade or a chained upgrade, or from whichever version they're doing that jump. And yeah, this is the kind of reaction that we get when we say that, okay, we don't have LTS yet.
So as we have learned why we need LTS, let us look upon the challenges it entails. So as we can see, it's just a rough comparison of Kubernetes support metrics. As we are all seeing the standard support across all the providers is basically supporting for 12 months, and and the LTS varies for different providers. So as we can see, basically this demonstrates the demand of the longer support window versions, and how we can how the industry is basically chasing for this. So definition, what constitutes standard support for Kubernetes releases? So it's basically a period of 12 months after a minor release version, during which the necessary fixes, CVs, bugs or dependencies are made from the patch releases. And the goal of the standard support is to provide the secure and stable and secure Kubernetes that can be used by a wide range of users and the environments. So how to define a LTS beyond standard support? So defining a LTS beyond standard support is basically in addition to how we are defining more than how we can basically optimize and use the LTS in a challenging way. Like basically, it has always been a challenging, but the length and the kind of basically the limited support as we are part of LTS has always been under discussion of like working group LTS, and deciding on LTS which policy we can be using is considers the stake, like we have to consider the stakeholders and the vendors so that basically they can plan ahead for without impacting the business. So will there be LTS for dependencies? So Kubernetes heavily rely on its components like containerd, CodeDNS, HCD, CNI plugins, and so on. So these releases should be available for Kubernetes fulfillment. So are we going to support these components as well? Well, yes and no, but we're going to discuss in the upcoming slides. And what about the patch releases? To support our minor patch releases, we must understand what type of patch we are basically releasing, which may include the CVE fixes, the critical bugs, and like any vendor specific or any feature we are going to uh, release in that patch. So how frequently we are going to address these issues through patches? Well, this will be discussing in our LTS scope.
So let's talk about patching strategy. Since all bugs cannot be a feature, we need to address them. And what drives the question is how much the bug is actually affecting a Kubernetes version or a specific feature. So these are the things that we need to discuss as a part of the um, as the LTS policy. Next, we have CV fixes. So as we know, at every point of time, someone or the other would have got a CVE, and it is very common. So addressing these CVEs becomes very much important because these actually cause security breach, sometimes a clear security concern for the normal business process. So that becomes very vital. Next, we have dependency bumps. As we know, Kubernetes, being a humongous project, is dependent on several other SIGs and other projects. So these set of dependencies needs to be updated proactively so that Kubernetes can work in synergy with other components. And any of these bug fixes and dependencies can also be done with these dependency bumps, through these dependency bumps. And long-term support should also take this dependency bump into consideration while defining the long-term support policy. Uh, as this image shows, it is a modern infrastructure built out of small blocks, but we can see that the entire infrastructure is hinging on that small block, which is whose criticality and like the stability is paramount. So this kind of hard dependencies and basics dependencies should be removed actually, so that the entire infrastructure doesn't depend on one small part of the structure. Go version bumps. So Kubernetes code base is written in Go. So doing the version bumps in Go and also fixing the CVs becomes very important as a part of LTS. And doing all these fixes, bumps, we should also ensure that the quality of Kubernetes is not compromised in the process. So it should provide the same stability and reliability that it does for any stable releases. So let's talk about maintenance efforts and expenses. So maintaining the CI signal for EOL releases is again a challenge. So for LTS that we are doing, basically these versions are not supported in the upstream. So what we did is that we had to go ahead and create our own Prow infrastructure to accommodate all these changes. And these periodic jobs, end-to-end jobs, are very, very resource hungry, as we already know. So this again comes with the, if it's resource hungry, means it comes with a high cost maintenance. So yeah, that is also one aspect that we need to consider while talking about LTS. Component knowledge and release knowledge is required for CVs and backports. So basically, whenever there is a bug or a CV that is identified, and we just want to backport, it's not a very easy process. There is a lot of manual effort that goes into it. and a lot of research how to fix it, whether it is compatible, whether the dependencies are matching or not. So having that component knowledge becomes very vital to do all that fixes. Knowledge gaps, so continuing with the previous point of component knowledge, understanding the issue, raising a fix requires a lot of manual effort, and that is something that we want to reduce and also make that, like, fill that knowledge gap. So along with that, basically we should also have new test cases to the CI which can automatically test those fixes that we do in the LTS versions.
So now let us talk about our implementation we did to overcome these challenges. So this is our approach, which states like once the standard support ends, how long we are going to support the any Kubernetes minor release. So we are basically providing for Tanzu like 12 months of like support releases, which has some kind of like policies in place. So we are only be supporting the critical CV bugs for our vendors, and which includes like any specific bug which you need to fix for the vendors that we basically include on support policy. The other part is like critical version update bumps or dependent components. This will, for example, like we are supporting the 1.24, which will include the basically the dependencies which we need to basically release for Kubernetes 1.24. Next is like effort for LTS, streamlining LTS release branching strategies for dependent component so that KTS can have a simpler LTS patches. So there should be a defined branch strategies for its dependent components. Not all follows a similar release cycle which Kubernetes follows. So it has also become difficult to manage these manage the LTS for those component release. So because not everyone in the community has the same defined approach. So as a result, we should strategize and maintain these branches manually for simpler LTS patches. So CVs. So in order to fix the CVs, we need to know like how we can find them in our repositories. So basically, the Trivy scan is a GitHub action we basically enroll in our internal for detecting the CV. So this GitHub action basically runs nightly job, and if there are any critical or like high severity CVs found, like the maintainer will get notified about this. The same, the same Trivy scan we have like proposed this in the HCD and CodeDNS. They basically following the same scanning strategies. As you can see, like I've provided an example for CodeDNS, like how if someone tried to push a commit, then basically, if someone every nightly this job is run, and the maintainer will get notified about the severity of this, which basically have in the CodeDNS. Next is like automated cherry picks for CV bug fixes based on the labels and milestones. So while keeping the LTS branches in sync, we need to understand like we must ensure the changes are placed properly. So in the Kubernetes repo, we have a cherry pick script. So we have basically utilized the same cherry picks and made the changes on top. So which will basically pick the changes which are happening. Like for, let's suppose we are supporting the 1.24. So we'll run this script and it will ensure that all the issues or the fixes which happened for the 1.24 or 1.25, we'll just try to pick up from this cherry pick script, which will basically search on the basis of labels and milestone attached to the issues. So by this, we can filter out without doing the manual effort. So then we can basically merge any PR like which is stable for our 1.24 releases. Next is like the dependent component do not have the release branches that we have discussed right now. Like, so the releases from main and master doesn't help with LTS and needs to be managed. The main and master branches are essentially maintained by them, but there are like some, there are some talk which happens in like, there is not many maintainers who are ready to support the release branches, or also there are not many changes happening in the repo. So because of that, they are not ready to basically start following the release, creating a branch of releases and cutting from them. So what we have implemented in our internally, we have created a release LTS branch from the basically LTS branch from the end of life release tag. So whatever the changes we are implementing will come under this release tag. The same thing we have tried to propose for Coordinates. As you can see, like this is a proposal I have proposed to the Coordinates to follow the release cycle cadence, which Kubernetes is following right now. So it will be easier for us to maintain and be consumed internally for our VMware purpose. Next is like maintaining separate parallel end-of-life branches is required to eliminate code conflicts and branch diversion, which helps the code stability. Like following the similar approach for creating the LTS branch. So this will basically solves a lot of like code conflicts as well, because all the master branches are being sit from the upstream, but internally if any conflicts happen, if you are not managing them, then it will basically uh, it will give a lot of time to basically debug and resolve the issue, which conflicts we need to merge or not. So, so based on that, we will pick the CV fixes, bug fixes, and maintaining all the changes we have implemented. And like we'll just be going to implement this in our LTS branches and do the releases accordingly.
So let's talk about the need for carry commits. So basically what happens is most of the um, code base has hard-coded values. So these are like needed to be parameterized in the downstream in for vendors and specific use cases. So in those cases, what we do, we add our own commits to make those hard-coded values parameterized, and these kind of pile up into a set of commits that we need to carry forward to each and every release that we make. So in that case, what we can do is we can just raise a commit to the upstream, and the upstream can accept it as a parameterized value. And that way, we don't need to maintain those commits as a part of this, and it will actually be beneficial to every other people who are consuming Kubernetes in that way. So this is one of those PRs which was raised by Dims and Adam, thanks to them, in parameterizing the Kupros image value. Let's talk about the CI infrastructure. So periodic jobs are needed to test end-to-end LTS releases. Since there is no community version, like no community support for the branches that we support as a part of LTS, all the fixes and backports that we do needs to be thoroughly tested before making the release. And for that, we have set up our own PROW infrastructure within VMware, and we run the same set of tests that upstream runs, but on the older versions, which basically means that whenever a PR goes into the repo, uh, we basically run the same sets of pre-submits and periodics that we run in the upstream to validate whether the Kubernetes that we're releasing has that same stability or not. Uh, Pre-submits, again, it is very essential to have them uh, even before a particular commit goes into to ensure that the Kubernetes doesn't break with any commits. And as we can see, this is the PROW infrastructure that we have set up in internal to VMware, and the first three are the pre-submits that we have, the last three are the periodics, and these are actually running on 124, which is out of support in the community. So new test cases, as we already discussed, is that it's required to do specific corner case testing for the specific bug fixes, the fixes, backports that we do on the older versions. So what do we do next? So basically, the thing is, we can look at the key takeaways that we have and the things that we have learned while tackling LTS. And I think the working group LTS will also benefit from those. So starting with defining the support scope with clear inclusions and exclusions, what to include, what not to include, CVs and bugs, specifically bugs that skew or hamper the core functionality of any feature. Those are the primary things that we need to backport, we need to fix in any LTS version that we do. Next is basically the CI signal. We need to have those particular tests and all to define that. So these are the minimum inclusions. Exclusions can be other stuff that basically doesn't on alpha features or something which is not that important. Selection of a KTS minor version to kick off LTS. So basically, we all need to decide on a specific Kubernetes minor version, which can become a potential LTS. How can we do that selection? We can actually think of any minor version which has the least number of alpha features and which is already being used, and a lot of effort has been gone into it, and it has been like being used by many of the vendors for some time now. And finally, establishing a well-defined upgrade path. So like we discussed that basically if we have a 12 to 14 month general support window and then the LTS starts, it will be very beneficial for the vendors to make incremental upgrades. And also due to these incremental upgrades, there will be less chances of breaking the Kubernetes itself. And also compatibility becomes a major issue. So basically LTS will, so once Kubernetes goes into that long-term support structure, it will, other components, other auxiliary components will also follow that support model eventually. Code, Containerd has already started supporting LTS, and they have announced it. Other auxiliary component like Prometheus has also declared LTS, and they are going to do that support. And that's all. That's all for today. And yeah, thank you, everyone.
We have time for one question.
Hello. Okay. Thank you for the session. This was very insightful. This is maybe a general question for working group LTS, but I'll just ask here to start the conversation. Are you all aware of auto-refreshing Kubernetes CVE feed?
Yes.
So in that, we are currently publishing in with JSON and RSS feed different CVEs that have been published in the past and that will come in the future. One of the feedback we got for that feed, and I am one of the maintainers for it from Six Security Tooling, was you don't have information about when this CVE is applicable. Like if this code which is vulnerable was introduced in 122. So if you're going to do an LTS for 121 or 120, you don't really need to do a backport. Would that be useful? And if yes, what would you like to see apart from that to support LTS in the CV feed?
Yeah, I think that would be definitely very useful. In that case, it will reduce the effort that goes into doing that research and back, like whether considering that CV as a CV for that for previous versions and stuff. And also the other thing what we can do is that we can flag that okay, this CV is for 124, but it is also applicable to the previous versions like 123, 122, and this identifying that thing and just doing an automated backport that okay, we know that same line of code is there for last 3 versions and we are supporting, so we can just do it and that can be automated, no manual intervention is required.
Thank you.
Thank you. Thank you, sir.